We're going to start the next section by talking about units. And if we are to compare all systems of units, it will really help us to see why we use certain systems and why we don't use others. So our aim for the section on units is to learn the English, metric, and SI systems of measurement. So we actually have 3 different systems of measurement that we're going to be talking about today. So again, to learn the English, metric, and SI systems of measurement. We're going to fill out this table going down each column, and then we'll work our way across the table. So we're going to start with the English system, or the imperial system, and this is what we use daily. And we see units of mass as things like the pound or the ounce. So remember, it's something like 16 ounces equals a pound. So where those numbers and those conversions came from are usually anecdotal and less based in science and how to convert one to another. So don't forget abbreviations for these things. Pound is LB, ounce is something like OZ, and we see these pretty regularly in our daily lives. For length, we use the foot and the mile, or even the inch. You should know these abbreviations. Foot is FT, mile is MI. How many feet are in a mile? Remember, this number is 5,280. So again, the conversions for these aren't as clean as some of the other systems we're going to be talking about today. For time, we use the second, and lucky for us, time is consistent across all different scales of measurement. So it would be very difficult if we had different time scales. Time is one of those things that's universal. The base unit for time is the second. So that can be abbreviated SEC or just S. It is seen in different ways and both are acceptable. For temperature, we use Fahrenheit. So we always keep an eye out for that 32-degree Fahrenheit day, and that's what we look forward to when we know that school is going to be canceled. We know 32 degrees Fahrenheit is very cold. We know 100 degrees Fahrenheit on a hot summer day is going to be much warmer. So our scale is known to us in terms of Fahrenheit. What we should be using is the metric system. And we should be using the metric system because it is based on the number 10. And you'll see as we start looking at converting how it works to be converting units back and forth between the metric system and how it's much cleaner to do it in metric than it is to do it in English. Metric mass is given in the gram. Gram is abbreviated G. And these are only the base units that we're talking about. So you may have seen things like mg for milligram or kg for kilogram, and we're going to be looking at that in a little bit. This is just to differentiate between the units, the unit systems. For length, our base unit is the meter, and we see that as m. And again, you've probably seen this more commonly as centimeter or maybe km for kilometer. But a meter being approximately 3 feet kind of gives you an idea of the scale of the meter compared to the foot or the yard. Again, time is consistent across all scales. Second, SEC or S are our abbreviations. Time has to be consistent across all scales. For temperature, they use Celsius, and Celsius we'll talk about in a minute. It makes a lot more sense in terms of properties of water because that's what it's based on. We know that 0 degrees Celsius is the freezing temperature of water and 100 degrees Celsius is the boiling temperature of water. So you can see these are nice, clean numbers. For the SI system, SI stands for International System of Units, and it actually comes from a French phrase that's initially inverted. But we're not going to focus too much on the SI system. We do want to talk about their base units because they are a little bit different than what we would use for the metric system. The base unit of mass in the SI system is the kilogram, so this would be abbreviated kg. For length, the SI system uses the meter again. So you can see a lot of consistencies between the metric system and the SI system, with the exception of the prefix for their mass unit. But they still use the same base idea of how they're doing their measurements. For time, again, time is consistent. Second, SEC or S. And for temperature, they use Kelvin. And Kelvin is based on the properties of gases. So we have the Fahrenheit in English, which was actually based on the properties of brine. So brine is basically salt water, and compared to something more the same throughout, like water or a gas, brine has varying composition. So because it has this varying composition, you're not going to get nice clean results, and even the type of brine can vary in its freezing and boiling temperature. So that's why it's not really useful to us in scientific terms, because it's based on things that we don't use daily. The metric system, again, is based on the properties of water, which will make sense to us, and especially converting back and forth. And then Kelvin is based on the properties of gases. The SI system is necessary for a bridge between the English and the metric system. SI is used in publishing of scientific papers where we have one group that uses English, one group that uses metric, and this is a way for everyone to know what everybody else is talking about. So you won't see the SI system a lot unless you are talking about reading a published paper, and they are always required to use SI system in published papers. So looking at abbreviations for these, and we saw some of them in the last overview slide that we went through. Abbreviation for kilo is K. So we've seen this in things like the kilogram, and we would just take the first letter of each of those, the first letter of the prefix as well as the first letter of the unit. So this would end up looking like kg. The meaning refers to the numerical meaning of that prefix. So when we see kilo, we see that that means 1,000 of something. So this is telling us that 1 kilogram equals 1,000 grams. If you're good with fractions and you can remember this is the same thing as saying 1/1000th of a kilogram equals 1 gram. Sometimes the top statement can be cleaner to use depending on how we're using it in our conversion statement, and I'll explain that in a future I will explain that in a future section. For deci we see has a D prefix. The unit example here, I'm just using the gram all the way down for consistency, so this would be something like a decigram. Unit abbreviation, again, we're just taking the first letter, so this would be something like DG. And the meaning of deci is 0.1 or 1/10. So this is telling us that 10 decigrams equals 1 gram, or 0.1 grams equals 1 decigram. So when we see the meaning, that meaning is always referring to the base unit. It's always how many of the base unit I need to equal that metric prefix on the unit. Centi is small c, and we're using the centigram, again, first letter of each one. So this would be abbreviated CG, and centi is 0.01. And we can think of this the same way we think of the number of cents in a dollar. How many cents are in a dollar? 100. So therefore, there have to be 100 centigrams in 1 gram. Again, you can think of this as a decimal or a fraction. So we would have 0.01 grams equals 1 centigram. But whatever makes sense to you to remember the conversion is the method I want you to use. Again, I'll show you how to use these based on what type of conversion you have in a future unit, in a future section. Milli is M. We end up with a lot of M's. We end up with millimeter, Mega is usually differentiated by a big M, but we'll look at that in a minute. So milligram, again, taking the first letter of each one, we get mg. We've probably seen this a little bit more frequently. The meaning for milli is 0.001. So this means that I have 0.001 grams in 1 milligram. Or looking at it the other way around, we have 1,000 milligrams in 1 gram. So this is our metric ladder, and this is a way to look at how we can convert from one metric unit to another. This is a good visual to have with you on a test, for example, if you're using notes to try to remember how to convert from one thing to another. But what this is telling us is starting at our base unit, the meter, the liter, the gram, whatever we decide to use for our base unit, we're looking at how the prefix compares to that base unit. So for example, kilo, we said the meaning was 1,000, and that tells us that there are 1,000 grams in 1 kilogram. Now, this looks at it the other way. This looks at it in terms of the metric prefix compared to the actual unit. So this is the same thing as saying that for every 1 gram, we have 0.001 kilograms, and that's telling us our meaning here. The number of times we go up these stairs, for example, 1, 2, 3, is how many times we are going to take into account that factor of 10. So this is 10 to the third. This entire jump up here is 10 to the third. And what do we know about 10 to the third? 10 times 10 times 10 equals 1,000, which is where that number came from. So we would have to multiply a gram by 1,000 in order to convert from gram to kilogram. If we're going the opposite direction, we can look at it the same way, except dividing by that factor of 10 rather than multiplying. So going from 1 to 10, just to deci, this is telling me that there are 10 decigrams in 1 gram. Or in other words, 1 decigram equals 0.1 grams. So what have we done? We have divided 1 by 10. If we go one step further to look at centi, this is telling us that we have 1 gram equals 100 centigrams. Or we could say 0.01 grams is 1 centigram, because we've taken that base unit, 1, and we have divided it by 10 to the second power, or in other words, 1 divided by 100, which is equal to 0.01. This is a tool. This is not necessary for you to use, for you to teach others to use. This is just one way that being able to convert between the different metric units, one way to help you convert between the different metric units. Devices in chemistry, and that's just a way for us to study, for us to keep our ideas straight. And if you prefer to take tests, for example, without using notes, remembering these different mnemonics are a way for you to easily recall the order of, in this case, metric prefixes. So one of the mnemonics used for remembering the metric ladder would look like this. King, Hector, died, drinking chocolate milk. So if you don't want to take out the time to draw out the whole ladder, but you can remember that King Hector died drinking chocolate milk, then this is an easy way for you to be able to reproduce this diagram as you use this to take a test and complete your conversions on a test. Please pause the video, take a moment to try these practice problems, resume your video, and come back for the answers, please. For these practice problems, we are looking for the word prefix in the metric system that represents the following numbers. And you can see this is the same thing we were looking at in this table. That first number was the number 1000. The matching prefix is kilo. So that is the answer to number 1. 1000 means kilo. For the second one, we can approach it in two different ways. We can either look at just the 10 and the exponent at the end because we know our base number is 1. So that means that we have 0.001. 10 to the negative third is 0.001. If you're familiar with your prefixes and you can recognize them just on 10 to that power, then that's how you can look at this problem. The other way is by taking this number out of standard scientific notation and turning it into a decimal. But you'll see that that number comes out to exactly the same. If we have 1.0 times 10 to the negative third, we're moving the decimal point 3 places to the left to make that number smaller. 1, 2, 3. So we get the same thing, 0.001. So this works out really nicely if your base number is 1. So we're looking for the number from the table that is 0.001, and that's right here, and that matches up with our prefix that is milli. So this one is milli. For number 3, we have the same situation we saw in the last problem. Our base number is 1, so we can ignore it. We're just looking at 10 to the third. 10 to the third power is, or 1 followed by 3 zeros, and that matches what we saw in the first one. So this is again kilo. In the third one, I have the number 0.089. So the way I want to look at this one is it might be easier to put it into scientific notation. So if we have the number 8.9 and we put this number into standard scientific notation, we want to see how many times we have to move it. 1, 2. So this number is 8.9 times 10 to the negative 2. So we want to recognize what this 10 to the negative 2 means. 10 to the negative 2 is 0.01. 0.01 from my table here is centi. So therefore my prefix is going to be centi.